Good day. The next topic we're going to look at today is coordinate geometry, and at this level we're going to look at straight line graphs which are represented by linear equations. So that's the relationship there. This will be the graph of straight lines, and we're going to analyze these straight lines in different ways. So a linear equation has the general form y equal mx plus c. This is what we call the equation of the line, the linear equation, and M and C have specific names. M will be the gradient, and we'll see that in more detail later, and you'll also see C in some detail later. C is the y-intercept, or the point on the graph where the straight line going to cut or cross the y-axis, and once it crosses the y-axis, that point going to be x is 0. So since we're looking at the graph of straight lines, first thing is how we're going to get a straight line. All we need to get a straight line is 2 points on a graph. So we set up an example here already. I have a graph and I want you to plot the points A42 and B68 on the graph, and we see how to do this already. X, Y, that's how we write a point. X, Y, that's how we write a point. So A42, I find X is 4 because this is the X axis, this is the Y axis, 4, 2. Again, normally you'll have a grid. I just wanted to show you. You could set it up in your book as well. It wouldn't be perfect or as accurate as a graph, but it's still a very close approximation once you space it out well enough and use your lines on your ruler and stuff. And now, unlike with the stats graphs, instead of having an L-shaped graph, we're going to have that plus shaped graph I was telling you about, because we're going to have negative components in these. So that's my point A, and then same thing for B, x, y, so 6, 8, both of them, x is 6, y is 8. And then to get my straight line, I just draw these two together. I already sketched it on the next page, so this time we actually have a nice straight line instead of my bend lines that are trying to draw freehand there. So we have a straight line, and what this whole topic is about is analyzing the different things we could do with just 2 points which form a straight line. So the first thing we're going to look at, and we have mentioned it before, is the gradient of the line. The gradient really means the slope or steepness, how steep this line is, and we already saw this represented by M in this formula here a little while ago. We'll come back to that a little later though. But this topic is really a series of rules and formulas, and you're responsible for everything you see here on your own. None of this coming on the formula sheet for CXC. So this is one of the first formulas you're responsible for. The gradient, which is M, is y2 minus y1 over x2 minus x1, and in some textbooks, so if you're doing sciences, you might use rise over run, you would notice. But for the mathematical part, this is more what we will be using, y2 minus y1, x2 minus x1. But where are these things coming out from? So if I want to find the gradient of the line AB, to form AB, I needed point A, which was 4, 2, just to refresh your memory, and point B, which was 6, 8. And remember the form a point going to take. A point is always take the form xy, xy. We would have done that previously. But since we have 2 points, all I'm going to do is call my first point, subscript them 1. And my second point, because it's the second point, I'm going to subscript them 2. So you realize now where the x1, y1, x2, y2 coming in. In order to have the pieces to substitute, because this is a formula, that's what I'm going to do next. So if I want the gradient of that line, again, I just write in back the formula, y2 minus y1 over x2 minus x1. So I'm pairing up the two y values and subtracting them. So I find y. So you realize not these two together. It's y2 minus y1. So looking at y2 is 8 minus y1 is 2. All over x2 is 6 minus x1 is 4, and then I work it out just like I work out a fraction. I work out my top first. 8 minus 2 is 6. 6 minus 4 is 2. Sometimes the answer will be a fraction, sometimes the answer will be negative. I choose a nice neat example just to explain. The gradient is 3. So what this number is just a numerical value we assign to the steepness of the line. And 3 is pretty steep, and you can see that by the line. This is a pretty steep line. You can think of it as something you're trying to walk up. And if I was trying to walk up this line, it's pretty steep to try and walk up or crawl up. It requires a little bit of work to walk up and crawl up. So the smaller that number, the flatter the line. In fact, as a general rule, and you'll notice it here, once you graph from left to right, going uphill, if I was walking from left to right, because that's how we read, you'll always get positive gradient. So the value for the gradient will always be positive once you have a line going uphill. It will be a positive gradient. If the line flat, it have no steepness, and if it have no steepness, that means the gradient going to be 0. And if we're going downhill, we still have a steepness, but because we're going downhill from left to right, we'll have a negative value for the gradient. So even before you work out some of the questions, especially for the ones with the negative part, which we would have, because that confuses students a little bit when we have those negative numbers there, just by the shape you already know what answer to expect. So if I have this shape going downhill and I get a positive answer, maybe I should check it back, or vice versa. If I have it going uphill and I get a negative answer, once it's going uphill, we're expecting a positive answer. Once it's going downhill, we're expecting a negative answer. And if it flats, well, the gradient is 0. So on to the next rule. The next rule is the midpoint of the line, and again it's our next formula. The midpoint is just the middle of the line, and to get the middle of the line, I just find in the average of the two x values, if you notice, and the average of the two y values, because I add up the two x values and then cut it in half. So I find in the average of the x values, average of the y values, and to still be a point, because this is going to give my x answer and this is going to give my a y answer, and it'll just be our next point on the graph, the exact middle point on my graph. So same thing like before. I had A was 4.2 and B was 6.8, and again x1, y1, x2, y2, because that'll be very popular throughout this whole topic, just to show you where the pieces come from. And to get the midpoint will be, I still have my formula on top there, so it'll be x1 plus x2. So x1 is 4 plus x2, so it'll be x1 is 4 plus x2 is 6 all over 2. Y1 is 2 plus y2 is 8 all over 2, and then I work it out. I just substitute first. That's how we normally do any formula. Substitute into the formula first and then work it out after. 6 add 4, 10 over 2. It just so happens both of them work out to be the same number. That's just a coincidence that it work out to 5, 5, but usually there'll be different numbers. So that's the exact middle point on the line, meaning if I was to go back to this original line here, the point 5, 5, I'll just put in a sketch on the graph, that will be the midpoint of my graph. That's the exact middle point on the graph, right? So this is the least popular out of the rules, which is the length of the line. You just want to find out how long the line is on the graph. So it's the square root of the top part in my gradient formula, or y2 minus y1, and I'm squaring it, plus the bottom part in my gradient formula, x2 minus x1 squared, and then just sub the numbers. Again, this is the least popular. I can't remember the last time it came, so it's not one of the more popular ones in terms of what you expect it to do. And again, I just substitute in to get the length. Square root, don't forget your square root sign. It will be, again, watching the formula there, same parts for the gradient if you know, y2 minus y1, so x minus 2 squared plus x2 minus x1, 6 minus 4 squared, 8 minus 2 is 6 squared, plus 6 minus 4 is 2 squared. Square means multiply yourself, multiply by yourself, and then multiply by 2, so 6 sixes, 6 times 6, 36, 2 times 2, 4, so my answer is root 40 units. If you want, you could find the decimal answer for that. It'll be 6 point something, but what we really want to look at is the main one, which is the equation of the line. So the equation of the line is one of the most important things in this topic. It's something that almost always comes, and it uses the gradient. So along with the gradient, these are the two most popular things you'll have for this topic. Alright, so to get the equation at any line, you always need two pieces of information, and those two pieces of information is the gradient, or in other words, I need a m and a point on the line, and a point is in the form xy. So I need a m and a xy, and what I'm going to do with that m and an xy, I'm going to stick it into that very first formula from the start that we had, y equal mx plus c. I said we're going to see it again. So that's the most important, the important information that we'll need. We need the m, and we need a xy, and we'll solve for c. C is not the answer. C is the missing part to the equation of the line, which is the y-intercept. We saw that before. So let me see how we're going to find this. So let me see. To get the equation of the line AB, first thing I need is the gradient of the line AB. Well, we found that in The first rule, the gradient of the line is 3, so I have my gradient is 3, and I need any point on the line. Most of the time you're only going to have 1 point on the line, but this question actually had 3 points on the line. It had A42, it had B68, and we even find the midpoint was 5, so I could use any one of these. It don't matter which one you use, I'm just going to pick one. I'm going to use A. Right, so we're using A, so I have my M, and A going to provide from the point XY, and I'm going to sub all that into Y equal MX plus, and the only thing we don't know is C. So I'm going to sub. So when I sub, Y is 2, so I have 2 is equal to M is 3. When letters close to numbers, by now you need to know that that means multiply, so that's 3 times X is 4, and I have this plus C, which I don't know. So we're working it out. 2 is equal to 4, 3 is 12 plus C. And I'm going to solve for C. Letters on one side, numbers on the next. So if I want the C by itself, I'm going to carry across that positive 12. What happens when I carry across positive 12? I'm going to get negative 12. So 2 minus 12, C turned out to be minus 10. What does that mean though? We already said C is the y-intercept. So if the y-intercept is minus 10, that means that's the point on the graph where it's cutting the y-axis. Now again, C is not the answer. I just want to demonstrate what C is. So from the graph we had here, this is the graph we had. What they're saying is, in any graph, if I was to extend back the line, it don't matter how the graph draw, but if I extend back the line all the way until it cut or cross the y-axis, in this particular graph, this is going to cut, sorry, again, going back to not using the ruler, right? This is going to cut at C equal minus 10. So if I was to draw back a straight line, not what I do here, but if I was to use the ruler and draw a straight line, the point where it cuts in the graph on the y-axis, where x is 0, we call that the y-intercept. So now that I have C and M, I could build the equation of the line, which is y equal mx plus c. So when I build this equation of the line, y and x will be the different points on the graph, so they don't change, but specific to your answer, we will have a m and a c. So now this is the form y equal mx plus c. M is 3, c is minus 10. And does this look familiar? It should, because this is really a function. So that's how this related to functions, by the way, right? Because once I have our equation of the line, is really the functions we was dealing with, and we could use the function to plot the points as we was doing last time. I just want to show you quickly, before the time run out in this video, what if we had used our next point? Let me say we use B68. So if I was to use, so this is a different point I'm using. M is 3, B is 68. And I'm doing the same thing. Y equal mx plus c. I'm subbing in. Y is 8. M is still 3 times 6 plus c. 6 3 is 18, so I get an 8 is equal to 18 plus c. When I carry across the 18, 8 minus 18 is equal to c. 8 minus 18, like I said, it doesn't matter which point I choose. If I choose the 5, 5, and you could try it back yourself, I'm still going to get c as minus 10. So that's what I'm telling you. It don't matter which one you choose. Once you do it correctly, you'll get the same answer. But in most questions, you're only going to get 1 point, right? As you'll see later on. Since we're starting up, we're just showing you a lot of the basics. This have an advanced part, which I'll look at in the next video, but these formulas are what you require for this topic.